Hey guys, welcome to today's online learning. As you can tell, we're super excited. Yesterday was super exciting, don't you think so? Adventure abounded. Anyway, so today what we're doing is we're going to continue that same starter that we did yesterday. We're going to practice writing an equation given 2 points, and that's going to super help us as we go throughout this unit. So the first thing is we need to find the slope. You can either use the slope formula, which is above, or you can do what I like to do, which is set up a table. So my table is x and y. I put my points in. This is x, this is y, this is x, this is y. If you want, by the way, to have notes to use on your tests, you will need to make them yourself. So that's important. All right, so right here, my change between 3 to 2 is I went down 1. And then from -5 to +10, I went up 15. Now my slope is always y over x. So I'm going to change my change in y, which is a +15, and divide by my change in x, which is a -1, which makes my slope, or my m, a -15, which if I was graphing would be down 15 over 1. Now, we're going to take point slope form, which is this formula right here. And I'm going to take this point right here because they're both positive. You can use the other point if you want. I don't want to, but it's up to you. All right, so right here, we're going to just start with a y. So I just write y. And then it says minus y1. That just means take y of your point. So y minus 10 equals, then I take my slope, so a -15. And then in parentheses, I'm going to put an x, and then it puts minus x1. So that means I'm going to do minus 2. My 2 is coming from here, and my 10 is coming from right here. Okay? All right. And then my next step is to simplify. So my first thing I'm going to do is I'm going to distribute my -15. So then I would have y minus 10 equals -15x plus 30. Then from here, I want to make it only y on the one side. So I'm going to add 10 to both sides. So I have y equals, and then I have a -15x plus 40. And there's my equation, y equals mx plus b. And again, when you have questions on this, please make sure that you're commenting them below this thing, okay? So what we're learning today is we're going to identify, which means we're going to be able to tell if two lines are parallel or perpendicular given their equations. We're going to be able to tell that information. And then the next thing says, so this is what we'll be doing over the next 2 days. This is tomorrow. I can write an equation of a line that is parallel through another line that goes through a specific point, or I can write an equation of a line that is perpendicular to another line that goes through a specific point. And we're going to learn how to do those. All right, so we need to know what parallel lines are. And you learned a little bit about parallel lines in 8th grade, and we talked about them a little earlier in this year when we solved systems. Parallel lines are lines in the same plane that have no points in common. In other words, they do not intersect. Okay, this is the symbol for parallel. Let me give you an example of it with my pretty little pen. That means parallel. Okay, two lines are parallel if and only if they have the same slopes. So these would both have the slope of 3 over 2. That's not a 2. 3 over 2. And this one also has a slope of 3 over 2. Now, if they're vertical lines, this would be the line x equals 6, and this would be the line x equals 9. Because they're both x equal, they will in fact be parallel, which you can see on this graph by the fact that this is straight up and down, this is straight up and down, and they will never have a point in common, even off of what I can see. All right, so now we need to be able to look at these two. I'm going to show you how to do this by hand, and then I'm going to show you how to use Desmos to check. So the first thing I'm going to do is I'm actually going to look at my m. Now, this one's already in y equals mx plus b. This is my m right here, so my slope is 2. This one's already perfect. The other one, however, is not set up in such a way that it's super easy to see my slope. So now I need to distribute my 2. So I have y minus 3, that didn't change. equals 2x plus 8. That's just 2 times x and then 2 times 4. Now, I've still got something next to my y that I need to get rid of, so it looks like this one. So I'm actually going to add 3 to both sides. And I end up with y equals 2x plus 11. Notice now, this one has my slope to be 2. So I know these two lines are in fact parallel. And we can check that if we go into Desmos. So here's my Desmos. And I'm going to type those equations in. So these equations are y equals, and then I'm going to do, nope. Okay, so I'll do this one over here on the left first. I mean, on the right first. So y equals, and then we have 2x plus 3. So there's my first line, and that would be it beautifully graphed. Then down here, I'm going to do this one. This one starts with y minus 3 equals 2, and then there's a parenthesis, and it says x plus 4, and then close parenthesis. Now, if you take a look at those two lines, can you guys see that they are parallel? I can even zoom out really, really far, and they stay two distinct lines. All right? So we just proved to ourselves that these are, in fact, parallel. Okay, so let's do this one. The first thing we need to do is solve it so it says y equals. So I'm going to subtract my 4x from both sides because 4x has absolutely no y in it, therefore I don't want it over there. So now I have 2y equals negative 4x plus 14. Now I'm going to divide everything by 2 so that this 2 is gone. So I have y equals, now I've got negative 4 divided by 2, and I get negative 2x, and then 14 divided by 2 is a positive 7. So this case, my slope is a negative 2. So let's check out this other one. So the first thing and only thing I have to do on this one is subtract the 2x from both sides. So if I do that, and I'm going to do my work over here, so it's very obviously not part of that problem. I'm going to subtract 2x, and I get y equals negative 2x plus 7. And my slope, again, is negative 2. Now, I want you guys, before I tell you, decide, is this parallel or not? You make the decision. And before I even tell you, let's go ahead and look at what it looks like on Desmos. So I'm going to clear my two equations that are in there, and I'm going to type these new ones. So these new ones are going to be y, or no, I lied. Hold on. Backspace. Okay, so we've got 4x plus 2y equals 14. So there's our first equation. And then I want my other equation. So this one over here. This one's going to be 2x plus y equals 7. So that one's kind of interesting. Let's see what happens as we get closer. What do you guys think is going to happen as we get closer? There doesn't seem to be two lines. Let's zoom in even closer. Are these parallel? What do you guys think? So even though the slopes are the same, these are in fact not parallel. Because they are the same line. Just, really get that in. I copied over it with a pen that made more sense. So these two lines are not parallel, but those first two are. Even though they have the same slope in the second one, they also have the same y-intercept, which makes them the same line. Now, we're going to decide which between all of these are parallel. Now, I will let you decide if you want to try to do it on Desmos or not. It's up to you. I'm actually going to simplify these all down so they say y equals. So these first two are already set up to be y equals, which is fantastic. So I'm going to do C. So I'm going to distribute my 3 So I have y minus 5 equals 3x minus 3. And then I'm going to add the 5 to the both sides. And I have y equals 3x plus 2. Okay, this may be parallel with something else. It may be the same line as something else. I'm not quite sure yet. All right, on this next one, I'm going to subtract x from both sides. And I have 2y equals, then I have a negative x minus 4. Now, you need to remember, whether or not you actually do, that the number in front of my x is a negative 1. And that's super, super important. Because when we take everything and divide it by 2, we just need to remember that it's the negative 1 divided by 2. So this is y equals negative 1 divided by 2, x, and then negative 4 divided by 2 is a negative 2. All right, let's take a look at these. Okay, is there anything with the same slope as 3? Take a look. Do you see anything? If you notice, C also has the same slope of 3. But because they both also have a 2, A and C are the same line and therefore not parallel. All right, so let's take a look at the next one. So on this next one, if you notice, this has a slope of negative 1/2. Is there anything else with a slope of negative 1/2? You may have noticed that D also has a slope of negative 1/2. And if you look, the 4 is different than the negative 2. So B and D are parallel. All right. Again, if you have questions about this, please take notes and please ask them. All right. A parallelogram is a four-sided shape with opposite sides being parallel. So we're going to show that A, B, C, and D is a parallelogram. We're basically going to show that this slope is the same as this slope. And we're also going to show, I'm going to make this pen a little bit thicker because it's hard to see, that this slope here is the same as this slope here. Okay, that's our goal. So we're going to find the slope of AB. And I like finding the slope of lines that I just have dots of. So AB, I go up 1, 2. So I went up 2. And then I'm going to go to the right 1, 2, 3, 4, 5. So I went over a positive 5. So my slope of AB is up 2 over 5. Now let's find our slope of BC. So BC is down 1, 2, 3, 4. And then it goes over 0. So this is undefined. And I'm just going to put UNDEF for undefined. Okay. Now if you take a look at CD, let's look at this one. I go down 2, so that'd be negative 2, and then over 1, 2, 3, 4, 5 to the left. So that'd be over negative 5. So a negative 2 divided by negative 5 is actually a positive 2/5. Is there any other slopes that we've already written that are the same? You might have noticed that this is the same as this. So these two lines here are parallel. Okay, so now our main goal is to see if AD is also parallel to BC. So let's see, from A to D, we go down 1, 2, 3, 4. So I went down 4, but then I don't go over anything. So that's over 0. Anytime I divide by 0, this is undefined. Well, if I have two undefined slopes, are they the same slope? And the answer is yes. These two lines here are in fact parallel. So now we can say that ABCD is a parallelogram. Does that make sense? We'll be doing, that's kind of what your level 4 will be like on the PC that will be next. Well, not next week, but the week following. Okay, perpendicular lines. The symbol we use for perpendicular lines is this little symbol here because it looks like it's perpendicular. This is also the symbol for perpendicular lines. Let me switch to yellow. It'll be a little easier to see. Well, it'll be green now, but here we are. Okay, so perpendicular lines are lines that intersect to form a right angle, 90 degrees. So it's two non-vertical lines are perpendicular only if and only if their product is a slope of -1. In other words, and horizontal lines are perpendicular, always. So this would be the equivalent of x equals 1, 2, 3, 4, 5. And this is y equals -1, 2, 3, 4, 5, 6, 7. These two lines are perpendicular to each other because they meet at a right angle. Okay, these lines are perpendicular because this has a slope of -3/2, this line right here. And then this line right here has a slope of 2/3. If you notice from here to here, we flip the number over and we flip the sign. All right, I'll give you a little bit longer to write that. If you need more time, please pause the video. Okay, lines that are opposite reciprocals are also known as negative reciprocals, are each other's perpendicular slope. So if I was given 2/3, perpendicular to that would be -3/2. If I was given -4, the perpendicular to that would be 1/2. So in the case of 2, if this is actually a 2/1. So if I flip this over, this becomes 1/2, and then I need to flip the sign, so now it's negative. If I want to find the perpendicular to +2/3, I flip it over, so that'd be 3/2, and then I flip the sign, so it'd be negative. This next one is 1/5. If I flip it over, that becomes 5/1, and then I flip the sign, so it'd be -5/1 or -5. If I'm given -3, I flip it over. Now remember, -3 is -3/1. So I flip it over. So that'd be 1/3. And instead of negative, now it is positive. So if I'm given a -1/4, then I flip it over. So now the 4 is on top and the 1's on the bottom. Instead of negative, now it is positive. Now 0 is interesting because the opposite reciprocal of 0 would be to flip it over. Well, technically, this would be 0/1. That's generally how we write fractions, right? So if we flip this over, I'm going to do 1/0. Well, if you notice, this is now undefined because we're dividing by 0. Okay. Any questions here? Cool. All right. So any questions, please leave them on the chat. Okay. You can identify if lines are perpendicular by checking the slopes. So you may have to change the equation so they're in y equals mx plus b form. So here we have two equations, and neither of them are y equals mx plus b. And again, we can look at Desmos for this, but Desmos isn't as exact as parallel. It's a little harder. All right, so the first thing I'm going to do is subtract 3x from both sides. And I'm going to end up with y equals -3x plus 5. So my slope here is -3. Now over on this one, I'm going to add x to both sides. So then I have 3y equals a positive, and I'm going to leave myself a little space to remind you of something, x plus 4. We have a positive 1x plus 4, but remember that 1 is technically invisible. All right, so now I'm going to divide everything by 3. So the 3's cancel out, and I'm left with y equals. Now notice we have a positive 1/3 x plus 4/3. Now that 4/3 is a little less important right now. What's important is that my slope is 1/3. Because this is -3 and this is a positive 1/3, these are perpendicular. Okay. So we're going to do this a couple more times. So we're going to try and identify two equations that are perpendicular. Okay, so the first thing you want to do is make sure everything says y equals. So I'm going to subtract x from both sides here. Now I have a negative 1y equals a negative 1x minus 3. Now I'm going to divide everything by negative 1. And I end up with y equals x plus 3. So this right now has a slope of 1. All right, let's take a look at b. So b, the first thing I would do is subtract 2x from both sides. So I have 2y equals negative 2x plus 5. Now I want to divide everything by 2. And I have y equals negative 2 divided by 2 is a negative 1, x plus 5 halves. So my slope here is negative 1. All right, let's take a look at c. So c is already set up, so it's y equals 1/2 x plus 8. So my slope here is 1/2. That one was real easy. Okay, let's take a look at d. So on d, I'm going to subtract x from both sides. And I have 2y equals negative x plus 10. Now remember, this is a negative 1x. So now let's divide everything by 2. And I get y equals negative 1/2 x plus 5. So my slope here this time is negative 1/2. Now we just need to identify two that are perpendicular. So we want numbers that are flipped upside down and flipped signs. So I've got a 1. What's 1 flipped upside down? So if we think about this as 1 over 1, flipped upside down would be the same thing, but we've also got to flip the sign. So we're going to flip it over. So this would just be 1 over 1 now. I'm going to write it with a different color so you know what I'm doing. And then we have to flip the sign, so it'd be negative. Is there anything that says negative 1? You've got it. It's this one here. So I would write A and B are, and I'm going to use the symbol for perpendicular. Now, why is it that this is not perpendicular to that? You've got it. Here, I'll write it with black. It is not flipped over. All right. If you have questions here, please, please, please put them in the chat. All right, let's go into here. Okay. So right here, we're going to decide what the slope would be to parallel to 1 and then perpendicular to 1. So on 1, my slope is 2. So parallel would just be 2. Slope is going to be equal. Perpendicular is going to be to flip the number over and then flip the sign. Does that make sense? So here, remember that this is actually 2 over 1. So if I wanted to flip it over, this becomes 1/2, and then I need to flip the sign. So right here, my slope is negative 1/3. Now I can tell what my slope is because it's always right next to my x. Okay, so my slope right here is actually this right here. So that's a little easier than having to solve in that case. Okay, so parallel is just going to be negative 1/3 here. If I flip that over, that becomes 3 over 1, and I make it positive, so then it'd just be positive 3. All right, so in this next one, this would be 2/3. If I flip that over, that becomes 3/2, but I need to flip the sign, so it's now negative. Now on number 4, we need to do a little bit of math because we need to put the points in our table. So we've got negative 1, 0, negative 5, 3. Now my change in y is up 3, so I know that my slope is up 3, and then we don't know how far over yet. So from negative 1 to negative 5, that is down 4. So that's positive 3 over negative 4. So parallel would be negative 3/4, because a positive divided by a negative is a negative. Okay, and then perpendicular would be positive 4/3. Because we have to flip it over and we have to flip the signs. Okay. If you have any questions on any of the things that we've done so far, please leave messages, please leave comments, and hopefully someone will answer it. And if not, I will answer it. Again, my office hours are from noon to 3 every weekday. And so please get a hold of me if you need my help with something. All right, here you go.